Howdy! In this mini-lecture we will discuss the latest report from the Intergovernmental Panel on Climate Change. This video will further emphasize the current and future trends and impacts of global climate change and discuss ways we may respond to climate change. The student learning objectives of this mini-lecture are: explain who the IPCC is and their significance, identify the 10 key points of the IPCC's fifth assessment report, distinguish between mitigation and adaptation, and explain a strategy for addressing climate change. IPCC is a scientific, intergovernmental body under United Nations. This panel was established in 1988 and produces reports that support the United Nations Framework Convention on Climate Change, UNFCCC, which is the main international treaty on climate change. Ultimate objective of the UNFCCC is to stabilize greenhouse gas concentrations to prevent anthropogenic changes to climate systems. The IPCC reports cover scientific, technical, and socio-economic information relevant to understanding the scientific basis of risk of human-induced climate change, its potential impacts, and options for adaptation and mitigation. The IPCC does not carry out its own original research, nor does it do the work of monitoring climate or related phenomena itself. The IPCC bases its assessment on the published literature, which includes peer-reviewed and non-peer-reviewed sources. Thousands of scientists and other experts contribute on a voluntary basis without payment from the IPCC to writing and reviewing reports, which are then reviewed by governments. IPCC reports contain a summary for policymakers, which is subject to line-by-line approval by delegates from all participating governments. Typically, this involves the governments of more than 120 countries. The IPCC provides an internationally accepted authority on climate change, producing reports that have the agreement of leading climate scientists and the consensus of participating governments. The 2007 Nobel Peace Prize was shared in 2 equal parts between the IPCC and Al Gore. The most recent IPCC report is the final installment of the fifth assessment report, commonly known as AR5. AR5 was released in 4 parts between September 2013 and November 2014. The 4 parts are the physical science basis, impacts, adaptation, and vulnerability, mitigation of climate change, and synthesis report. The 2 responses to climate change are mitigation, pursuing actions that reduce greenhouse gas emissions to lessen the severity of climate change. Examples include working towards energy efficiency, relying more on renewable energy, protecting soil, and preventing deforestation. And adaptation, or accepting that climate change is happening and pursuing strategies to minimize its impacts on us. Examples of adaptation include building seawalls and modifying water management strategies. I've provided a hyperlink to the IPCC's website on eCampus if you'd like to read more about this panel or their reports. The synthesis of AR5 is a 40-page summary of the 3 previous reports and is designed for policymakers. Overall, AR5 is the strongest, most robust, and most comprehensive report released by the IPCC to date. This report has stronger language, and the overarching message is that the warming is unequivocal and changes are pervasive. The report says we must take actions to end our dependence on fossil fuels, or we will face more warming and long-term severe, pervasive, and irreversible impacts for humans and ecosystems. Few people would read the 40-page synthesis report, much less the entire AR5 report, but what they will read is an abbreviated list of the main points within that 40 pages. The remainder of this mini-lecture is derived from an article published in the GRIST, titled The 10 Things You Need to Know from the New IPCC Climate Report. I have read both the GRIST article and the synthesis report and can confirm the GRIST accurately summarizes the AR5 synthesis report into manageable lists that most everyone can read and understand. A link to the GRIST original report is provided in eCampus. Let's begin, shall we? The first take-home point from AR5 is that we are responsible for climate change. According to the report, human influence on the climate system is clear, and recent anthropogenic emissions of greenhouse gases are highest in history. The atmospheric concentration of greenhouse gases, specifically CO2, CH4, and nitrous oxide, is unprecedented in at least the last 800,000 years. The source of these higher emissions is the burning of fossil fuels, which has driven economies and a growing global population. The graph here shows the increase of global anthropocentric CO2 emissions. Just in case you're wondering, it is possible to tell what sources of CO2 come from volcanoes and other natural occurring sources, and which come from anthropocentric sources. We know from such chemistry tests that the carbon from our emissions is distinguishable from natural sources, and that ultimately it is our sources that are causing the increase. Take-home point number 2. Global climate change is not some far-off threat that we are speculating will happen. Global climate change is happening now. Each of the past 3 decades has been warmer and warmer than any previous decade on record. Sea levels are rising, Arctic sea ice is shrinking, and crops are changing, often getting smaller. The world is getting wetter and storms and waves are becoming more intense. The graph on the top of this slide shows global average combined land and ocean surface temperature anomaly. Anomalies are more important than absolute temperature changes, because a temperature anomaly is the difference from an average or baseline temperature. Notice that since about 1900, the trend in surface temperature anomaly has been moving in a positive linear direction, indicating that observed temperature is warmer than the baseline temperature. The graph on the bottom shows that the global average sea level change has been increasing since the same time. Take-home point number 3. The effects of climate change are going to get worse. The graphs in this slide show how much global mean sea level will rise and global average surface temperature change will rise under several different emission scenarios, all of which to some degree show these changes will intensify. We can expect longer and more frequent heat waves, extreme precipitation events that are more intense and more frequent, oceans to continue to warm and acidify, global mean sea level will rise, and 3.7 to 4.8 degrees Celsius warming or more by end of the century. Take-home point number 4. A great deal of the most recent warming has been in the oceans. As we discussed when we study marine systems, colder water is denser, while warmer water is less dense and rises to the surface. As the oceans warm due to increased global temperatures, the water expands. This causes stronger storms, rising sea levels, and eroding coastlines. To give you a point of reference, about 90% of the energy from the atmosphere and climate system that has been added since 1971 has gone into the oceans. You might say to yourself, well then why isn't the ocean warming faster than the atmosphere? The reason is that one of the emergent properties of water is that it has a high specific heat, meaning that water can absorb a great deal of heat before it actually increases in temperature. This principle is apparent when you boil water on the stove. The pot the water is in will become hot to the touch well before the water changes temperature. That is because the metal the pot is made out of has a lower specific heat than water. This property of water is what helps it to regulate our climate. However, it's important to note that even small changes in temperature in oceans can be detrimental or deadly to the organisms that call the ocean home. Take-home point number 5. The oceans are becoming more acidic. Specifically, the ocean is 26% more acidic, and pH continues to decrease. The acidification of the ocean is commonly called the other CO2 problem. As we've discussed before, the ocean absorbing CO2 from the atmosphere causes ocean acidification. Ocean acidification threatens organisms with hard calcium carbonate shells, such as shellfish and coral, and organisms higher up the food chain that rely on these organisms in one way or another within the food chain. Since the beginning of the Industrial Revolution, the pH of ocean surface waters has fallen 0.1 pH units. While this may not sound like much, remember that pH is on a logarithmic scale that spans from 1 to 7. Each step on the scale represents a 10-fold difference in hydrogen ion concentration. Therefore, a change from pH 7 to pH 6 means that there are 100 times more hydrogen ions in the water. The 0.1 pH unit change in the ocean equates to a 30% increase in acidity. Models indicate that unless we reduce emission rates, we could expect the ocean to become 150% more acidic by the end of the century. This would mean an end to beautiful coral reefs and fisheries as a source of food for a growing population. Take-home point number 6. The countries that will be most affected by climate change are the developing nations, where we are all at risk and vulnerable. This figure shows the widespread impacts attributed to climate change. Notice every region of the world will experience effects, but these effects will differ based on location. Recall I stressed this point in the Global Climate Change mini-lecture. The little bars next to the symbols indicate the confidence in attributing the effect to climate change. The more bars represent the greater statistical confidence in the link between the observed or forecasted effect and climate change. In the U.S., we can expect melting of glaciers, snow, ice, and permafrost, droughts, floods, and water shortages, wildfires, reduced marine resources, coastal erosion and other ocean-related effects, impacts to terrestrial ecosystems, and impacts on human health, human livelihoods, and our economy. Globally, some of these human impacts will include new poverty traps, a more volatile and unstable food system, exacerbated health problems, displaced people, weakening of country infrastructures, and conflicts or wars over dwindling natural resources such as water and fuel. Take-home point number 7. Plants and animals are significantly more vulnerable than humans. As we mentioned in the Global Climate Change mini-lecture, organisms are adapted to their environment and less capable of managing the effects of climate change. For example, global warming modifies temperature-dependent phenomena, such as timing of migration and breeding. A very specific example of this is caribou migrations in Alaska. It has been warmer earlier in the season, which causes the spring to come earlier. However, migration patterns are often based on seasonal changes, not dependent on climate, such as time of day. The caribou are migrating to their spring feeding and mating grounds at the same time each year, beginning this journey when the daylight hours begin to lengthen at the end of winter. Before the effects of climate change, the plants of the spring mating grounds were blooming and blossoming right when they arrived, providing plenty of nutrition to support the population and pregnancy of the females. However, because it warms earlier in the year now, the plants are at their peak before the caribou arrive, meaning that when the caribou do finally reach the mating ground, the plants they rely on are not as abundant. This has caused the population to dwindle in size. Another effect from climate change is that species now have to move toward the poles or up in elevation to stay in the same temperature range in which they are adapted. Climate change is estimated to threaten 20 to 30% of species with extinction. In terms of effects on vegetation, more CO2 may increase plant growth, but droughts, fire, and disease will decrease plant growth. This is an example of a positive feedback loop because the effect of climate change will reduce plant survival and growth, and without the plants there will be more CO2 in the atmosphere, which will intensify climate change. Take-home point number 8. We must switch to renewable energy sources by 2050 and phase out fossil fuels by 2100 to avoid the most damaging, potentially irreversible impacts of climate change. These impacts include the sixth mass extinction, global and regional food insecurity, negative impacts on human activities, and limited ability to adapt to the changes. To avoid these impacts, we need to make sure our greenhouse gases are cut severely by the middle of the century. Ideally, we should aim for emitting nearly zero CO2 and other long-lived greenhouse gases by the end of the century. In this graph, we see the risks associated to climate change are dependent on cumulative carbon dioxide emissions. Notice that the severity of the effects are directly linked to CO2 emissions. The more cumulative emissions, the more severe we can expect effects to be on ecosystems, weather events, distribution of impacts, global aggregate impacts, and large-scale singular events. This might all seem depressing and disheartening, but there's hope. Consider take-home point number 9. We already have the answers we need to address climate change. The technology exists to make the changes we need to make. Furthermore, research has shown over and over again that economic growth won't be strongly negatively affected by climate change mitigation actions. But we must do this together. We must have a global response to climate change. According to the IPCC, effective mitigation will not be achieved if individual agents advance their own interests independently. Cooperative responses, including international cooperation, are therefore required to effectively mitigate greenhouse gas emissions and address other climate change issues. The 10th and final take-home point is that while the AR5 report is dire, the scientists were openly and unquestionably taking a conservative approach to the report, meaning the effects could be much worse than the report forecasts. According to the Bulletin of American Meteorological Society, like most scientists, the IPCC focuses more on avoiding type 1 errors, which are false positives, rather than type 2 errors, which is not claiming something is happening when it really is. So what are we to do? I listened to a NASA climate scientist speak at a convention in 2014, and he provided the following recommendations for how we should make meaningful change. Number 1, let our actions match our words in terms of your priorities and whom we care about. Ask most people who matters the most to them, and they'll say their families and their children. So we say we care about our children, but our actions contradict our statements. If we really want to provide for our children, we must overcome our selfish ways and take action to create a future for them that allows them to live and thrive in a world that is safe and which contains the beauty and diversity of life that we enjoy. Number 2, end global poverty. We cannot achieve a sustainable world when half of the world's population, more than 3 billion, live on less than $2.50 a day, and more than 1.3 million live in extreme poverty, living on less than $1.25 a day. When people don't know how they will feed, clothe, house, or support themselves and their families, they do whatever they can to survive and are not concerned about the environment or their impacts on it. And who could blame them? These people represent a vast group that could help solve the many problems we face if we were only able to break the cycle of poverty. I'm not talking about food stamps or other social support programs for people living on $20,000 or less a year. I'm talking about global food, education, family planning, and housing programs that will lift the poorest of the poor out of their current situation. Remember, economics is one of the 3 central pillars of sustainability. When we have half of the global population living in such conditions, we are nowhere near sustainability. Number 3, stand up for gender equality. As we discussed in the global human population lesson, the ultimate source of most environmental problems is our massive population. Poverty is perpetuated by uncontrolled human population growth. There simply are not enough resources for everyone. When women are given equal rights, educated, and allowed to determine the number of children they have, all of society benefits. Countries that suppress the rights of women and who do not allow them or enable them to be educated are wasting 50% of their potential. Communities and therefore nations in the world will be better able to tackle and solve the environmental problems of the day if women are given equality in all aspects of life. If you're not passionate about the environment, that's fine. I get it. Not everyone is. But do you care about your posterity? Do you care about human welfare? Do you care about equality? Do you care about human rights? If so, then there is a cause out there for you to get behind, support, and educate people on that will make a difference in terms of how we address climate change. You are the future. I know that may sound sappy and cliche, but it's the truth. The decisions you make in life will shape the world you live in and the world your children live in. Make a difference in the world by finding your passion and standing up for it. I hope I have left you on a slight hopeful note. This concludes this mini lecture on the IPCC's most recent climate report. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline. Thanks and gig 'em!